So hello guys, today we are going to solve a leetcode question, contiguous array. Okay, the question number is 525 and it's a leetcode daily question. It's for today, that is 16th March 2024. It's a medium level question. Okay, but if we try to solve it, everything is easy. Okay, we just try to get on to the solution. Even if you are new to this channel, what we do before solving the question is, first, we'll try to read the problem statement, and then we eventually go on to the solution. Eventually, go into solution. I don't directly tell the solution. I just make you develop the intuition of how to think before arriving onto the solution. Okay, so we don't do that here. That just I'll just give the solution and just cram it and just write it. No, 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 no. I'll just tell you how to think. Okay, so and the users that are currently here, like previously subscribed, you also know the process. Okay, so first let us start with the problem. We'll start by reading the problem statement. Okay, so what are we given? Given a binary array nums, return the maximum length of a contiguous subarray with an equal number of 0 and 1s. Okay, so what you are given is, basically you are given a nums array. First, what is before solving any question, you just write what is given to you. Okay, so you are given a nums of size n. Okay, and you write what you have to find. What you have to find? You have to find the maximum contiguous subarray, which contains equal number of zeros and ones. Equal number of zeros and ones. Okay, so this is our condition. This is what I have to find: equal number of zeros and ones. Equal number of zeros and ones. Okay, so how can I do it? How can I do it? Basically, if I just try to give you an example of what the question is trying to say. Example. Okay, what the question is trying to say before. Basically, if this is my example. Okay, so what are the contiguous? What can be the contiguous subarray in this? Like, if I try to see how many zeros and ones, like if I try to see how many subarrays consist of equal number of zeros and ones, I can clearly see that this subarray, okay, this subarray, basically not including this, just this, okay, this part, this contains equal number of zeros and ones. 0 becomes 2 times and 1 comes 2 times. Okay, and if I just see this subarray, this also contains equal number of zeros and ones. Like one consists of 2 times, 1 has a frequency of 2, 0 has a frequency of 2. Okay, so this is what I have to find. This is something what I have to find, because I have to find this contiguous subarray. Okay, and basically I have to find the longest of it. Okay, so if I am given with this example, just with this example, 1010, what is the contiguous subarray? Basically, what are the subarrays in this? Okay, first we'll try to find out the subarrays. Okay, so 1 is my subarray, 10 is my subarray, 101 is my subarray, 1010 is my subarray. Second, 0 is my subarray, 010 is my subarray, that's it. Okay, and 01 is also my subarray basically, and 1 is my subarray, 10 is my subarray, and then 0 is my subarray. So if I try to just iterate all the subarrays, does this contain equal number of zeros and ones? No. Does this contain? Yes. So I have a max value. I'll just update it. Okay, I'll update it to 2 because this is a length of 2. Okay, so this is approved. I'll come to this. Does it contain equal number of zeros and ones? No. I'll come to this. Does it contain equal number of zeros and ones? Yes. Is it greater than my current maximum? Yes. 4 is greater than 2. So my maximum would be updated. My maximum would become 4. I come to this index is 0. Contains just a subarray contains equal number of zeros and ones? No. So this gets disapproved. This contains equal number of zeros? No. This contains? Yes. But is it greater than my current maximum? No. I come to this. Does it contain equal number of subarrays? No. basically equal number of zeros and ones? No. This, yes, but it is still less than 4. It is still less than 4. This, no. Okay, so what is my maximum? What answer is I get? I get maximum as 4. I get maximum as 4. Okay, so now I know what I want to do. Now I know what I want to do. So I can just arrive to the brute force solution for this. I can arrive to the brute force solution for this. What can be my brute force solution? If this is my sub array, basically if this is my array that I'm given. Okay, I can basically generate all the sub arrays. And how can I generate it? I can generate it by starting at this index, basically putting I in this index, and starting j till the nth index. Okay, so for the first index, j would travel from, basically if this is my indexing, if j is here, this is my indexing 0, 1, 2, 3. Okay, for the 0th index, my j would travel from 0 to 3. Okay, for the first index, my j would travel from 1 to 3. Okay, for second index, my j would travel from 2 to 3. Okay, for third index, my j would travel from 3 to 3. Okay, so I would get some subarrays like 0, 0. Okay, 0 to 0, 0 to 1, 0 to 2, 0 to 3, 1 to 1, 1 to 2, 1 to 3, and then 2 to 2, 2 to 3, and then 3 to 3. Okay, so these are my subarrays. These are my subarrays. These are my subarrays that consist of equal number of basically no, now I have to filter out equal number of zeros and ones. Okay, so I just showed you the solution, and now I have all the subarrays. I can just find out by iterating and using a map. Okay, using a map and by iterating all of the subarrays, I can just find out what sub array has the maximum length and what can be my answer. Okay, so if I just try to dry run for this code, 1010, okay, or I'll just change the test case. Basically, if I just take for 0, 1, okay, so it would be easy for you to understand. Okay, so 0, 1. What are my sub arrays for this? Basically 0, then 1, and then 0, 1. Okay, these are my sub arrays that are generated. So for this first test case, I can just basically make a map. Okay, I can make a map for this sub array, and I can store my 0 value. My 0 comes one time. Does my 1 comes anytime? No. Okay, so I'll just compare my occurrences of 0 as well as 1. Are they equal? 1 comes 0 times. So are they equal? No. So this is not my answer. I'll just skip it and move forward. I come to 1. I create a map for this. I count my zeros occurrences. 0 comes 0 times and 1 comes 1 time. Is the occurrences equal? No. No. Okay, I come to this. I make a map. My map store 0 1 time and 1 1 time. Okay, so are they equal? Yes, they are equal. Okay, so this will be my answer. So what will be the maximum length in this case? Maximum length would be 2. Okay, so this was the brute force solution. But if you try to analyze the time complexity of the solution, so making all the subarrays would take me O of n square time, because as we have 2 pointers I and j, and in the worst case, both of them, not the worst case, basically for generating all the subarrays, this would travel for n times and this would travel for n times. So n into n becomes n square. And what is my space complexity? As for each subarray I am generating, so there is basically O of n auxiliary space, basically O of 2, not O of n, O of 2. Okay, so O of 1 basically. Why? Because this space is like only 2 spaces, right? You know that this is gonna be 2 spaces. So O of 1 space. So O of n square time complexity and O of 1 space. Okay, but can I optimize this? Can I optimize the time complexity? Let us see. Okay, So if you just observe what you are given with the question, what you are given in the question, okay, you are given that the sub-array to be valid should contain equal number of zeros and ones, should contain equal number of zeros and ones, and you know that in a sub-array only two numbers are there, only two numbers are there, only two numbers are there. What are the two numbers? Basically 0 and 1, basically 0 and 1. Okay, so if I try to think, how can I just identify, how can I identify when my 0 and 1 becomes equal? Okay, just think like this. If I just take it as a sign positive, if I give 0 sign positive and 1 as negative, okay, and I take my sum as 0, okay, so for every occurrence of 0, if I just increase my sum, and for every occurrence of 1, if I just decrease my sum, so whenever my sum would become 0, that means that it contains equal number of zeros and ones, equal number of zeros and ones. What I just said, I just tell you. Okay, suppose basically you are climbing a mountain, okay, so this is the 0 side and this is the 1 side, okay, so this height is equal on the left hand side and the right hand side, okay, basically this is equal to this, okay, so as I increase to this point, okay, and if I decrease to this point, and on ground again, this is 0 level, okay, this is 0 level, okay, 0 would increase my sum, and 1 would decrease my sum, okay, basically if this is my 0 level, what 0 would do is 0 would increase my sum, and at some point 1 will decrease my sum, so if at any point, okay, so this may it be number x, okay, so if at any point my sum becomes 0, that means I am at 0 level again, okay, I am at 0 level again. So this is the distance that I traveled, basically in the horizontal way, this is the distance I traveled, so this will be the size of my longest subarray, okay, this will be the size of my longest subarray. What I just want to say by this, like, if I am given with this 1010, okay, I am given with the sum 0 at initial stage. Sum 0 is stored at -1 position. Let it be. Okay. So if this is my subarray, this is my array, okay, I'll just come to this point. Okay. What my one would do is, my one would try to decrease the sum. So the sum would be decreased. It becomes -1. Okay. Sum would decrease. It becomes -1. Okay. When I come to this, my sum becomes 0. Basically, it is just like that. If you are given with +3 and you are given with -3, if I tell you, you just add them, what you will get? 0. Okay, so if you get the equal number of positives and negatives, if I tell you, you just try to add it, you will get a net sum 0, right? So this is the intuition that we are following. Okay, I am just given with two numbers, and I have to figure out when they become equal, in occurrence. So I can just give them a sign, positive and negative, positive and negative, and whenever my sum becomes 0, or I can say that my overall charge becomes 0. When charge becomes 0, that means that the positive content and the negative content is equal. Positive and negative content is equal. Basically positive and negative, if we combine positive and negative salt, basically positive and negative ion, it will become a salt, right? It will become a salt. So the same way, okay, 0 would increase my sum and 1 would decrease my sum. So whenever my sum becomes 0, my sum becomes 0, okay, my sum becomes 0, that means whenever my sum would become 0, that means equal number of ones and zeros are present. Ones and zeros are present. Okay. If I just try to show you this test case, 0 0 0 1 1 1. Okay. So I'll come to 0. My sum is 0 at the start. My sum is 0. Sum is 0 at the start. I come to 0. Okay. My sum would increase. So my sum is right now 1. Okay. I come to the first place. I come to this. Basically following the zero based indexing, I come to the first place. So I come to this place. My sum becomes 2. My sum becomes 2. Okay. I come to this. Just remember that my 0 would increase the sum. 0 is my positive sign and 1 is my negative sign. Okay. So just remember, I'll come to this. I'll come to this. It is 0 currently. So my sum would increase. Now my sum is at positive 3. Okay. When I come to 1, okay, my sum would decrease. 3 minus 1. Why? Because 1 has a negative charge. So it would decrease my sum. So sum would become 2. Sum would become 2. Okay. Sum would become 2. I come to the second one. I come to this. My sum would again decrease because it has a negative charge. Okay. I come to the last one. Last one. My sum would again decrease and my sum would become 0. My sum would become 0. Okay. So what I just observed it, I started at index minus 1. I started at index minus 1 and I again came up to a sum 0. Again come up to a sum 0. Okay. So this whole length would give me a sum 0. Would give me a sum 0 because this just simply means that equal number of positives and negatives are present. Positives and negatives are present. Okay. Positives and negatives are present. Equal number of positives and negatives are present. So I'll just take this whole length. 3 plus 3 is equal to 6. So 6 is my answer in this case. 6 is my answer in this case. Okay. 6 is my answer in this case. Basically, if I get a sum 0, at any time, I'll just declare it my answer. Not declare, basically I'll just store it. I'll just store the current length in my max. Okay, in my max. Okay, in my max. So if I just like I'm given with this test case 1 0. Suppose I'm given with 1 0. Okay, 1 0. So what I'll do is I'm given with some 0. I'm given with some 0 at the starting. I'm given with some 0 at the starting. Okay, some 0. What I'll try to do is when I encounter 1, I'll decrease my sum. My sum would become minus 1. And when I come to this, my sum would increase. My sum becomes 0. So my sum becomes 0. So this whole is my answer. This whole is my answer. So my max value becomes 2. Max value becomes 2. Okay. Max value becomes 2. Okay. So whenever my sum becomes 0, till now what we have found that whenever my sum becomes 0, just store the length. Just store the length in mx. Okay, basically if I am given with something like this 1 0 1 0, then 0 0 0 1 1 1. Okay, so this would become 0 but here my mx would be 4, here my mx would be 4. When I come to this, my it would become plus 3 and then minus 3, so it will also become 0. But if you see, if my sum till here is 0, that means all the digits till now have sum up to a sum 0, because if you see, my 0 occurs basically 5 times and my 1 occurs 5 times. Okay, so it would result in an overall sum 0. So this would be my answer, this would be my answer. Okay, this would be my answer. Okay, this would be my answer. Okay, so this is my first observation, that whenever my sum becomes 0, just store the length and return the length at the last. Okay, but suppose you are given with some this chess case. Okay, 0 0 0 0 and 1 0 1 0 0 0 0. Okay, you are given with something like this. So if I just follow the approach that I just gave, that 0 would just increase my sum and 1 would decrease my sum, 1 would decrease my sum. So if I try to do this, I'll come to this. My sum would increase. My sum was 0. My sum would increase. My sum would become 1. Okay. I come to this. My sum would become 2. I come to this. My sum would become 3. I come to this. My sum would become 4. I come to this. My sum would become 5. Okay. So if I come to this, my sum would become 4 again, because 5 minus 1, 1 would become negative. Okay, so sum would become 4. I come to this, my sum would become 5. Sum would become 5. If I come to this, sum would become 6. Sum would become 7. Okay, not 7, basically 4 and then again 5. Okay, because 1 would reduce and sum would increase by this. Sum would become 6. Sum would become 7. Sum would become 8. Okay, so if I just try to observe closely, this subarray, okay, this subarray, my sum 5 that I had till here, is the same sum that I have here. This is because basically if you are just trying to add 5 plus 0 with something, it would result in 5 only, right? So if positive 5 has some subarray that is resulting to 0, so this would come as 5. Okay, so if my sum is currently 5, I can just say it like this: if my sum is currently 5 and if 5 has occurred before, that means there is a possibility of some sum. Okay, there is a possibility that some subarray is there that is equal to the sum 0, that has a sum equal to 0, okay. Basically consider these arrays. Okay, I am just summing up to here, so 1 2 3 4 5, and this I'll just leave this, and this has a sum again 5. Okay, there are sum again 5. Okay, so what I can say is, if I was summing till here and every digit just increases or decreases my sum, okay, so these three indices must be summing up to a whole 0. Why? Because if they were not summing up to a whole 0, because if there was plus 1 or even minus 1 or any other number, my 5 would not come. Okay, so x plus what number can be x? X plus what number can be x equal to x? 0. Okay, so I can just do it like this: 0 is equal to x minus x. Okay, so if there comes a x till here, I'll just check if there is a x before. Okay, if there is a x before, and if there is a x before, that means there can be a subarray that has a sum equal to 0. Okay, so if I just try to say it again: 0 0 0 1 0 1 0. Okay, just this. Okay, so 1 would result in a sum 1, this would result in a sum 2, this would result in a sum 3. Okay, so till here my sum is 3. If I come to here, my sum would become 2, my sum would become 3, my sum would become 2. Okay, my sum would become 2. Okay, my sum would become 2, and here my sum would become 3, and here my sum would become 3. So if I just try to closely see, my sum is already existing. My sum is already existing. Okay, sum is already existing. Here also my sum is already existing. Okay, so I can take this subarray. I can take this subarray. I can take this subarray, and I can take this subarray, because if my sum is currently till here, so x plus 0 is equal to x, x plus 0 is equal to x. So if this is occurring before, I'll just make sure to subtract it. I'll just make sure to subtract it. Okay, so if this is subtracting, if this is occurring before, if this has occurred before, okay, I'll just subtract it. Okay, I'll just subtract it, and I'll just store it in my mx. I'll just store it in my mx. So my mx would overall contain the maximum number. My overall this would contain the maximum number. So I would be needing an unordered map here. Unordered map here. Why unordered map? So that it can store my sums. Okay, so that it can store my sums. Okay, and whenever I get that my sum is occurring again, basically I'll store the index with each sum. Okay, so if my sum is occurring again, that means there can be a subarray that is summing up to 0, subarray that can be summing up to 0. Okay, so this sum can overall be reduced like this has some index, right, and this has some index stored before, okay, so I minus mpp of sum, okay, I minus mpp of sum, okay, so this would give me the maximum length. This would give me the maximum length. Yes, if I try to just explain you again, 1 0 1 0 is my array. Okay, I'll just start with 0. I'll come to here, my sum becomes 1. This is my map. Okay, my 0 is stored as -1 index. Why? Because if till here is my answer, I have to include all the subarrays. So 0 1 2 3. Okay, 3 minus of -1 becomes 4. Okay, so this can also be an answer. Okay, so I come up to the first index. Is 1 already in my map? No, I'll just store it in my map. 1 with 0. I'll come to here, basically -1 with 0. I come to here. Okay, my sum would become 0. Is 0 in my map? Yes, 0 is in my map. I'll just compare the indices. So 1 minus of -1 is equal to 2. My mx is containing 0 right now. So mx will contain 2 because 2 is greater than 0. So mx will be updated. Okay, now I'll come to this. My sum would again decrease to -1. So is -1 existing in my array? Yes. I'll just again compare it. 2 minus 0 is 2. Okay, so 2 is not greater than 2. Okay, so my mx would remain the same. I come to this index. My sum becomes 0 again. Is 0 in my map? Yes. So 3 minus of -1. So it becomes 4. Is 4 greater than 2? Yes. So my max would become 4. Okay. If I just try for this test case, 0 and 1. Okay. My sum is currently 0. I have it in my map. Okay. I will store 0 with -1 for obviously the whole subarray. If my whole subarray is the answer, so 0 and then 1 index, first index. Okay. 0 and then the first index. I come to here. My sum becomes 1. I'll check if 1 is stored in my map. No, 1 is not stored. So I'll store it with this index. I come to this. my sum becomes 0. Is 0 stored in my map? Yes. So I'll just subtract 1 minus of minus 1. It becomes 2. My mx was containing 0 because it was 0 initially. So mx would be updated as 2 is greater than 0. So mx would be 2. Okay, but now my pointer would come here, and this would be returned. This would be returned. Now I'll tell you for this test case that it won't run. Basically for 0, 1, 0. For 0, 1, 0. What would be in this case? For the 0, 1, 0. Okay. I have it in my map 0 with minus 1. Basically, okay. So my sum is currently 0. My sum is currently 0. I come to here, my sum becomes 1. Okay. Is 1 in my map? No, I'll just store it. I'll come to here. My sum becomes again 0. Is 0 in my map? Yes. I'll just make sure to just subtract it. So it becomes 2. So mx now contains 2. Mx now contains 2. I come to here. Sum becomes 1. Okay, sum becomes 1. Is 1 in my map? Yes. Yes. I'll again try to do 3 minus 0. It's basically 2 minus 0. So it becomes 2. Is 2 greater than 2? No. Okay. So I'll just return this mx. So mx would 2 would be returned. If I just try to code my approach, what I need is, first I need an unordered map. Okay, I need an unordered map. I need a sum. I need to iterate through the array. Whenever my current num is equal to 0, my sum would increase, else my sum would decrease. And if I find that my MPP already contains the sum, I'll just update it. I'll just try to update it with this. Okay. Else just show this first index. Okay. Return mx, and what mx will be at start? Mx equal to 0. Okay. What I did here is basically I just, if it is already present in my map, okay, I'm not updating its index every time. Why? Basically see. Suppose 0, 0, 0, 1, 1, 1, okay, and then 0, 0, 0, 1, 1, 1, and then basically 0 and 1. Let's suppose it is 0 and 1. Okay, so I'll just try to iterate. Sum becomes 1, sum becomes 2, sum becomes 3, sum becomes 2 again. Okay, so sum becomes 1, sum becomes 0, sum becomes 1, sum becomes 0. Okay, sum becomes 0. But if I just try to iterate, when I'll come to this index, I'll just look that my 2 is already stored in the map. So I'll just compare it. So 0, 1, 2, 3. 3 minus 1 would be stored. 2 will be stored. But will I update this index? Into my map? No. Because if I update this index, if any other 2, suppose basically if this is equal to 2, if this is encountered, okay, so the difference between these two is less as compared to the difference between these two. Okay, so what I'll do is I just try to store the first index of the particular sum, so that if that sum occurs again, I have the maximum of the length, okay, maximum of lengths of all. Okay, what I'm trying to say is if x plus 0 is equal to x, right? So any number of these can be like any number of zeros can be added. And if it is again looking for x, if it is again equal to x, okay, suppose basically if I just remove this, so my number of zeros would decrease, right? And if it has a length, so my overall length would decrease, right? So if I don't want to decrease this, so I'll just let the zeros remain here. Okay, let the 0 remain here. I'll just let the 0 remain here. Okay, and I'll store the first occurrence. That's why I didn't update it. I just updated it for the first time. I'll just try to run it. Okay, what is the problem? Let's see. Okay, what I missed just, I'll have to store this basically at the -1 index. Okay, okay, I'll try to submit. Let us see what we are getting wrong. Sum equal to I. Basically, not this, sum equal to I. Okay, I'll try to run it and I'll try to submit. Accepted successfully. Okay, so if I just try to give you a summary, I just made a map. And whenever you get the occurrence either you get 0 or you get the same sum again, that means there exists a subarray in between that has a sum 0. Why? Because x plus 0 is only equal to x. Okay, so this 0 can be any number of elements that are summing up to 0. Okay, so just I'm doing this, I'm updating my sum and I'm checking for the sum occurrence before. If it is occurring before, I'm just editing my sum. Okay, and I'm just making my maximum length, updating my maximum length every time. If I just try to analyze the time complexity, I'm just running a loop for one time. So the time complexity is O of n. Time complexity is O of n. Okay, and what is my space complexity? As I'm using an unordered map, space complexity is O of n. This was the overall solution to the question. If you have any doubts, you can just ping it down in the comments. And if you like the solution, do like, share, subscribe. Thank you, and have a nice day. Bye bye.